Okay, so in this video, we're just going to take what we did in the first video with direct inverse joint variation and set up what look like application problems. Again, you're looking for the keywords like direct or inverse or joint. So in this case, it says the number of pounds, so that's your first variable right there. So pounds is directly proportional, so we're going to be doing that regular proportion. To the number of kilograms that you are. So those are the two things you're comparing. Since it's direct, it's regular division, so we're going to do pounds over kilograms. And I forgot to mention at the beginning, this is actually in your practice packet, so if you're trying to find where this is coming from, I'm just kind of getting a couple setups done with you. I'm not doing the rest of the problems out. You will have to do that on your own. But just looking for the key information is important with these. Writing the particular equation means we're just going to write down, in this case it says Cadence steps onto a scale calibrated in kilograms and finds she is 50 kilograms and she knows she weighs 110 pounds. So you would do 110 over 50 is what you would use. And that's what you're going to use to figure out how much a person would weigh if they're 100 kilograms. You would do 110 over 50. You want to figure out pounds, so that's what you're going to put in as your x over 100. And then you can use that to solve the rest of the proportions in there. For part D, you don't have to do that if that question bothers you. If you're curious, you could just do it in your head and figure it out, but you don't have to write that down on the paper if that question makes you uncomfortable, and I totally understand that. We're going to skip over number 2 because it's also a direct variation and go right to problem number 3. Again, I'm not doing all of this with you because this is part of your practice packet. Okay, if you look through number 3, it states that the volume of a fixed amount of gas, so volume, is, it should say is, not in, inversely, so it's inverse proportion where we're going to be multiplying the two things. It's inversely proportional to pressure. Some of the units of measurement on here are a little weird. You might recognize some from your actual chemistry class. PSI, pounds per square inch. That's not really stuff you need to 100% worry about until you're labeling your final answer. So in this case, it's saying the pressure is 46 and the volume is 360. So we would do 360 times 46. And then it asks what pressure would be necessary to compress the gas at a volume of 276 cubic feet. So you would set that equal to the 360 times 46. And again, I will let you have the fun of solving that. With your final answer, what you get, you will put x equals your number with PSI as your units after. And again, the next one is going to be very similar because it's also an inverse proportion. If you skip down to number 5, which says chemistry problem, this one says temperature and actually gives you a variable to use for that. Varies jointly. So we underline the jointly with the product of volume and pressure, so V and P. So again, if we're writing a particular equation, we're just writing the expression that would go with it using the numbers given. So temperature is 294, volume's 8,000, and then the pressure is 0.75. And again, you're going to use that to set it equal to on the next section or next question, part B, to figure out the temperature. So you'll have the missing piece on the other side of your proportion to solve. Okay, so now that you're finished with this, your goal is to go back and complete numbers 1 through 10. After doing that, you're going to do the haiku assessment. That involves 1 through 10. And then you will finish the application problems after you do that. So make sure that you do the original 1 through 10 first before the application so that you definitely complete the haiku assessment during class time.